This is a video to correct part of the worksheet that I shared with you yesterday, I think. So here I have three vectors. So the column vector A is equal to 5, -2, B is equal to 1, 7, C is equal to -7, 0. They ask you to write as a column vector 2A. So 2A is equal to 2 times the vector 5, -2. Whenever you are multiplying the vector with a scalar, you just need to multiply the first component by the scalar and the second component by the scalar. So it's 2 times 5 and 2 times -2, which is equal to 10, -4. So the outcome here is 10, -4. This is a final answer that you need to write. They ask you to write as a column vector 3b minus c, so 3b minus c. It means that you are multiplying the vector b by 3, and then you are minusing the vector c, so -7, 0, which is equal to 321 minus -7, so plus 7, minus 0, so you don't really care if you add a 0 or not, it's the same thing, so it's equal to 10, 21. So this is a final outcome, 10, 20, 21. Now work out the magnitude of A, give your answer as a third number. So the magnitude of A, you just need to do the square root of 5 squared plus -2 squared. So it's equal to 25 plus 4. It's equal to square root of 29. Square root of 29, this is third number, you just keep it like that, right? They didn't ask you to write it as a decimal number, so third number, you just give the exact value that you got. All right, so this is for the first question. For the second question, let's carry on with the second question. So for the second question, ABCD is a parallelogram. You have BC is equal to 5, -1, DC is equal to -2, 3. So BC is equal to 5, -1, DC is equal to -2, 3. Okay. Find BD. BD. So BD. Well, I can introduce whatever letter in this vector. So I can write it like that, BC plus CB. Why I use the C? Because the given vectors here, they are using the letter C. So I see C here and C here. Well, to get exactly the vectors that I have in the exercise, I just need to change, well, I think this one is C, D, not B, right? Yeah, because I have BD, so BC plus CD. I just introduce the C in the middle of these two. So BC is equal to 5, -1, and CD is equal to minus DC. So minus, well, let me write it like that, minus DC, right? So it will be 5, -1 minus DC. DC is equal to -2, 3. So the outcome will be equal to 5 minus -2, so plus 2, -1, -3. So the outcome is equal to 7, -4. So this is a final outcome, 7, -4. So this is for the first two questions. Let's go further. So the second, the third question. Let's read it together. Third question. All right, so A is a point. A is a point with coordinates 2, 3, and you have AB is equal to 5, -4. Find the coordinates of B. Well, the vector AB, how did we find the component of the vector? It's always XB minus XA, YB minus YA. So I already know the component for A. So it's xb minus 2 and yb minus 3. So I have two equations here. I have xb minus 2 is equal to 5, yb minus 3 is equal to negative 4. So I will be able to get the value of xb. xb is equal to 5 plus 2, which is 7, and yb is equal to negative 4 plus 3, so negative 1. So I know the coordinates for b. B is equal to 7, negative 1, right? This is how you need to see it. For example, if they ask you to represent it, I have, what is A? A is equal to 5, negative 4. So 1, 2, 3, 4, 5. So this is A, 1, 2, 3, 4. So this point here is A. After that, I have the B, 7, negative 1. So 5, 6, 7, and 1. So this is B. So we said that AB is equal to 5, negative 4. It means that to go from A to B, I need to go 5 to, wait a minute. To go from A to B, well, wait a minute, the component for A, or the coordinates for A are 2, 3. So I put the point A in a wrong point. So the coordinates for A are 2, 2, 3. So 2, 1, 2, 3. So 2, 3. So this is A. So to go from A to B, I need to go 5 squares to the right and going down for 4. So 1, 2, 3, 4, and 5 exactly. And then I need to go down with wait. I need to go wait. I need to go 5 squares, and then I need to go down with 4 squares. So 1, 2, 3, 4, 5. Yes, exactly. And then I need to go down with 4 squares. So 1, 2, 3, and 4. Exactly. So I got exactly the correct coordinates for B. You can use the method that I just showed. So you just pull the point A, and then you go with 5 squares to the right, and you go down with 4 squares till you get the position of B, and then you read the coordinates for that. But I want my students to know how to solve that using algebra. It's easier and it's better. Right, next question. Let's take 3. So question 3, you have the diagram shows a trapezium, and and the trapezium ABCD. So I have BC is equal to 2A, BC is equal to AD, and AB is equal to X, AB is equal to vector X, AD is equal to the vector Y. Okay, find in terms of X and Y AC. All right, so I have AC. I need to get AC. You can even draw it to see what we are talking about. So this is the vector AC, right? So this is the vector AC, and we are looking for it. So the vector AC, I can write it as AC is equal to AD plus BC, right? And DC, what can I do with this? I don't have anything about DC. So how can I express DC? Well, did they say anything about? They said that BC is equal to 2BC, right? So if I will introduce B in the middle of DC, maybe I will gain something. So I will have AD plus DB. So DB, yeah, plus BC. Right. And for this one, I will introduce the A. So it will be AD plus plus what? Plus if I will introduce the well, what will I gain from here? I will have DA plus AB, right, plus BC. Right, so I have the value of BC, I have the value of AB, I have the value of, well, AD and the DA, they kill each other. Well, maybe from the start, I should have introduced the B, not the D, right? So I have AB is equal to X, vector X, and BC is equal to 2AD, and AD is equal to Y, so plus 2Y. So this is the expression of what I'm looking for. Well, from the start, maybe I should have done this. AC is equal to AB plus BC, right? I shouldn't even introduce it the D, right? But it's totally fine to try and get values, right? It's totally fine with that. Yeah, right. So what about DC? DC, this vector DC. Well, maybe I need to introduce, well, let's try to introduce the B. If I will introduce the B there, I will have DB plus BC. And DB, I can write it in a different way. So DB plus, maybe I need to introduce the A directly. Yeah, I will introduce the A directly. So GA plus AC. And this is better, I think, because GA is already here. It's minus AD plus AC. AC is already done for me. So minus AD is equal to negative Y. And AC is already done for me. So X plus 2Y. This is exactly X plus Y. Right. Don't forget always to add that line and the vector. So this is my final vector here, right? And I'm done with the first two questions. Let me carry on with other questions. All right. Let's return a bit. So the point is such that AE is equal to X plus Y. Use your answer to part A to explain that AECD is a parallelogram. So I remember that we got a DC is equal to X plus Y, right? So I have that DC is equal to AE. They have two equal vectors. It means, well, let me return to the graph here. So we have DC is equal to AE. It means that I have something like that. A should be, not A, E should be here. And if I will join these 2 points, I will have a parallelogram, right? Now, whenever you have two vectors are equal, it means that they have the same magnitude and they are parallel, right? So here I can say that DC is parallel to AE, and I have DC is equal to AE. Well, one of the things to introduce a parallelogram is that if you have two opposite sides or two opposite vectors are equal. So this is exactly what happened here. What happened here is that I have AECD is a parallelogram because I have this equality, right? So this is exactly what I have, because from the previous lesson, from a previous question, I showed that DC is equal to x plus y. And this is exactly the value of AE. So this is what I conclude, that ECD is a parallelogram. Right, so this is for the first 3 questions in the worksheet. I hope you understood. Let me know if you need more explanation about anything. Thanks for watching. Bye-bye.